Okay, after going through all the activities in the previous lab, you may feel tired because you are using the calculator to do the calculations. One of the main disadvantages of using the calculator is you have to do each and every calculations one by one. The other disadvantage is, let's say you want to change a particular parameter and do something. For example, let's say you want to change the frequency of a periodic signal and then plot it again. And even thinking about that will drive you crazy. So today we are going to learn a tool which can be used to minimize your work. So I emphasize that what we are going to learn is to make our life easier. But as we always have witnessed, unfortunately, things which are there to make your life easier sometimes make your life difficult if you don't take it properly. So please pay attention to each and everything that we are doing here, and also then you can follow what we are doing, and then you will be comfortable with what we are going to do today. And also you can use some of the techniques that you learn today for your projects. Okay, now what is this tool? Today we are going to learn about computer programming. Right? And basically what you do is we will learn how to give instructions to computer so that you will get what you want. Right? For example, let's say I want to plot some parameter x versus t, right? So this is what you want, and how you instruct to the computer is you can simply say, for example, something like plot t versus x. So if you have commands like this, you can achieve what you want to get, and here you will get your expectation implemented. Okay. And what is the difference between a computer and a calculator? In calculators, you give instructions one by one. But in computers, you have the option of writing a program. Basically, a program is a set of instructions. Right? Set of instructions. So you can write set of instructions and then run. For example, I can, let's say, define x equals something like Vm cos omega naught t plus 5. So this will generate x, and then I say plot t comma x. So assume that these two are two commands. Now in a computer program, we can write them into one text file and then execute. We call it as execute or run. Right? So that is what we are going to learn today. And when we talk about computer programs, a large number of names will come to your mind. For example, you may have heard about programming languages like Java, C, C++, what else? Python, right? These are few to name, right? Then there was very old language called as Fortran, right? Basic and the discontinuous. But for our exercises, we are going to use a soft programming language called as Scilab. Before going into Scilab, I have to mention one thing. There's a software, similar software called as MATLAB, which is one of the most popular platform to work in scientific and mathematics communities. But MATLAB is commercial software. Commercial means you have to buy it, right? But Scilab is free of charge. So that is the main reason why we thought of introducing use of Scilab for doing your activities. Of course, some of you may be used to MATLAB and you will find they are almost same, except there are few variations in the instructions, and also some of the functionalities and toolboxes available in MATLAB are not available in Scilab, but we can do a lot of things even with Scilab, right? There's another software which also I can recommend called as Octave, which also comes in between Scilab and MATLAB. This is also free and open software. Okay, now let us try to get our first experience into Scilab. To run Scilab, I have to find where Scilab is located. Sometimes you can see the Scilab icon on your desktop, otherwise I will search for Scilab. Here you can see the Scilab icon. So this is the icon and this how you run it, right? So by clicking on this you can run it. Let me reduce. What I will do is I will be running Scilab now. In Scilab you can implement a lot of mathematical functions. That is one reason why it is popular among scientific communities, right? For example, today we are going to learn two very powerful features of Scilab. One is the implementation of vectors and matrices. The other one is how to deal with complex numbers. Apart from that, you will learn how to use trigonometric functions and also how to do numerical integrations as we have discussed in the lecture. Okay, now when you enter into the Scilab environment or even MATLAB environment, you get a screen like this, right? And in this screen, this part is called as the Scilab console, or sometimes we call this as the workspace. And also sometimes you may see this window and these windows also on your environment. This is called as the variable browser. Now at the moment you don't see anything here, but when you start defining variables, they will appear here, right? Now before going into programming, let us try to directly give command to the Scilab and see how they are executed. So I'm going to start with a very simple command. Let's say I want to assign value 2 to a, or in other words, I want to make a equals 2, right? So I simply type a equals 2 and enter. See, what the computer has done has appeared here, and also in the variable browser, the variable name a has appeared with its value 2.
Now pause the video and try to do this yourselves.
Okay, next we are going to learn a small variation for this. Now when you implement a command on the command prompt, or even when you write a program, always the Scilab responds by retyping what you have done and just to tell that it has completed the work. But sometimes this will fill your workspace with unnecessary entries like this. So usually we don't allow these things to appear on the screen, right? So what we do is we say a equals 2 and after the command we put the semicolon. Don't see anything happening there, right? But the value 2 has been already assigned to a. Now let us give value 3 to b. You can see b has appeared in your variable browser. And finally, I am going to say c equals a plus b. Now we have given 3 commands. And here you can see c has already become 5. If I want to see the value of c, I can even type c here, enter, and you will see c here.
Now pause the video and try to do this yourselves.
Okay, now let us move on to little bit advanced functions. As I mentioned before, one of the main or key feature in MATLAB is it allows you to define vectors and matrices. So let us first define a row vector and also we define the column vector. So let me say I want to say a equals, right? There's no need to put capital letters, but I'm using capital letters usually to represent vectors and matrices. So let me say a equals square brackets 2, 5, 6. Close the square brackets. You press enter, a will be assigned with 2, 5, 6. Right? So this has created the 1 by 3. That means it is a row vector. Now suppose I am going to create another vector b equals. I am going to make it column. So to make it column, what I have to do is, in the previous case I have left spaces between each entry, but now I have to put semicolons. So a semicolon will define a new row. Right? So let me enter something like 3, 1, 4. Close the square brackets. Now you can see you get the column vector.
Now pause the video and try to do this yourselves.
Okay, now we can apply various matrices and vector operations on these. For example, let's say I want to do transpose. You know what happens when you apply a transpose to a row vector, it becomes a column vector and vice versa. So let me say A transpose A, and then I put these quotes A transpose. So 256 has become like this. Similarly, I can put B transpose. Also, one thing to notice, I can get any command that I have executed by pressing the up and down arrow keys, or you can get them from this command history. Right? In the command history, you can see all the commands that you have executed are appearing. So you can go there and click, or you can press the arrow keys. Now it will give you all the commands that you have pressed. Now I want to put B transpose. You are going to get it like this.
Now pause the video and try to do this yourselves.
The next operation that I am going to introduce is vector and matrix multiplication. Right? For example, let's say I want to multiply A with B. I can simply write A multiply Multiplication, we are using asterisk sign, A multiplied by B. You know, A is a 1 by 3 matrix and B is 3 by 1. So the result will be 1 by 1 matrix. Similarly, if I do B multiplied by A, where B is 3 by 1 and A is 1 by 3, you will get a 3 by 3 matrix.
Now pause the video and try to do this yourselves.
Okay, now let us see how to define the matrix. Let's say I want to define matrix M equals, first row I will have 2, 5, 6. Let's say I want to put 2, 5, 6 in the first row, and I'm going to define the 3 by 3 matrix. Go to the next row, I enter semicolon. Let's say I'll put 3, 1, 4 to the next row. Then I go to a new row, 1, 2, 3. When I implement this, you see 2, 5, 6, 3, 1, 4 and 1, 2, 3 has appeared here.
Now pause the video and try to do this yourselves.
Now let us see some operations that you can implement with matrices. For example, you know how to get the inverse of M. You can simply type INV M. You can find inverse of any matrix. Similarly, there are commands like determinant.
Now pause the video and try to do this yourselves.
Now let us learn few more commands. Now let's say after doing all these things, you can see my variable space or variable browser has got filled with variable. Sometimes I want to start everything fresh. So I want to get rid of all these things, right? So how can I clear all the variables that I have defined? I can simply type clear. You can see the variable browser has become empty. Similarly, another question that some students have is, after some time you will see your console becomes dirty. Dirty in the sense, it will have a lot of commands, error messages and so on. So, if I want to get clear what has appeared there, I simply type CL, which stands for clear, C, which stands for console. So when you type CLC, it will clear the console.
Now pause the video and try to do this yourselves.
Now to illustrate some more properties, let me take another example. This time let me take A equals 2, 5, 6. Then let's define B equals 3, 1, 4. Now if I try to multiply these two things, what do you think? Can we multiply two matrices? First one is 1 into 3, second one is 1 into 3. So the matrix multiplication is not defined. Right? So if you try now, you will get an error message which says inconsistent row column dimensions. But suppose I want to multiply A with B element by element. What do you mean by element by element? I want to multiply 2 with, let's say, 3 of B. Then I want to multiply the second element of A with second element of B. And I want to multiply the third element of A with third element of B. So there's a special way that you can execute this command, that is by placing a dot, A dot multiplication B. This will ensure that A will be multiplied by element by element. So let us execute that and see, and you will see you will get the answer with element by element multiplication of A and B, as you can see here. Now let us see A squared. Right? Here also, if you put a dot, you will get element wise square values.
Now pause the video and try to do this yourselves.
Now let us try to do something useful for our activities. First I will clear everything and okay. Suppose I want to create a plot. So let's say I want to create a plot of a parameter, say our parameter x varies with t or time, where x is equal to t squared. And I want to make this plot. So I have to prepare first an array where t is stored, and then I have to calculate x by making it equal to, now you learned how to write it in MATLAB, you put a dot and square. Okay, now how to create this vector t? Let's say I want to have this in space of 1 or 2 or 3. Let's say I am going with step number 0.1, 0.2, 0.3 up to 1. Then I want to calculate this thing. So how can I define something like this? Of course, you already know one method, right? You can put it as an array. If you want to get it as a raw vector, you can put simply 0, 0.1, 0.2 up to 1. Or you can define it as a column vector like this by putting semicolons. But the problem is, suppose there are 1000 values in between 0 to, let's say I want to define a number in this range up to 10,000. So your life is going to be difficult because you have to enter all these things. But there is a way to automatically generate something like this. So let us learn that in this section. So what I want to do is, I want to create a vector with this the starting point and then the gap size 0.1 and is the end number, right? So we call this as step size. So you have a starting point, step size and end. We can easily do this in Scilab by simply typing t equals starting number, that is 0, colon, then the step size which is 0.1 and then colon and the ending number which is 1. This will give us a row vector as shown. But if I want to get a column vector, I can put a square bracket, it will define a normal vector and get transpose of that. So when I enter this, you will get a column vector with all these values. Now let us try to create x as x equals e dot square. Not the dot there. Now suppose we want to show these things side by side. I can simply type square bracket e x close square bracket and you will see the result side by side as shown.
Now pause the video and try to do this yourselves.
Okay, now suppose I want to plot x versus t. So I can simply type t comma x, plot t comma x. And as you can see, you will get a nice graph like this.
Now pause the video and try to do this yourselves.
Okay, now having experienced this, now we will see how to make some modifications to your graph so that it will look more appealing, right? First, something missing in this graph is it doesn't have a grid. Usually in the graph, when you have a grid, you can easily reference points. So to get the grid, I will execute the command. There's a command called as xgrid. Enter. Now let us go to the figure and see what has happened. Now you can see the grid has appeared, which is a very useful feature for a graph. Okay, another thing that you may have noted is, although we have used a finite number of points to plot the graph, when it appears, it is automatically connected with straight lines, right? But let's say we want to show the sample points instead of a line connecting like this. See how to do it. You try plot t comma x comma, within quotes you can put a marker, right? Let's say a circle like this, and now you can see instead of the line you get a set of markers.
Now pause the video and try to do this yourselves.
Now let us see if you want to change the color of the plot. Right? The color information also added to the plot command by typing a color name. For example, when I type color R, it gives color red. So if I say G and let's say the marker is dot, now you can see you are getting green color dots. And also by typing the marker size like this, you can change the size of the marker. Let's say 20, and you get the size of the markers has been enlarged to size 20. And next we will see how to change the thickness of the line, right? So here I am not going to put any marks, but I am using color X, K means black color. I simply type line width and then I'll give a width, right? Let's say I'm going to give 5 as my line width, and you will get a thicker line this time.
Now pause the video and try to do this yourselves.
Okay, I hope now you have enjoyed your session with graphs. Now let's see how to add few more features into your graph. Let's say I want to add labels to x-axis and y-axis, right? So let me plot the graph. Then I want to put a time axis, and also I want to mark the y-axis, and also I want to give a title, right? Because any graph should have the axis label and also titles. So to get the x-axis, I can simply type x label within quotes anything. So I have put t per second, and you can see it appears now as text. Similarly, to get a label for the y-axis, I can simply type y label, and my y label will be x in volts, and you will see how it appears. Similarly, I want to give a title to the graph. I can simply take title and type whatever you want. For example, the graph of x versus t. And witness how the title appears.
Now pause the video and try to do this yourselves.
To end the session with graphs, let us say I want to see markers also on this graph, right? In addition to what you have plotted here, I want to plot markers on top of this. So how can I do this? Usually when you plot one thing and then plot another thing, the original graph will be erased, right? So that can be controlled by typing set bracket GCA, bracket GCA stand for the graphic axis. So GCA brackets, and we have to type the option auto underscore clear. And by setting this function off and on, I can, so if I take off, what will happen is that graph auto clearing facility will be switched off. That means when you plot one thing and then you plot another thing, both will be plotted on the same graph. So let's see. So I'm going to plot red circles after executing this, and you will see the red circles are appearing now on the same graph. Using the same technique, you can plot two graphs on the same axis. So for example, if I type plot t comma, let's say something like x in the graph, so you will get in the original graph. Then on the same graph, I'll be plotting a different function. Let's say now I am going to plot, right, the same thing but dash line. So now what I have plotted is x and then x squared, but x squared I have plotted using dash lines.
Now pause the video and try to do this yourselves.
Okay, now let us do our final section, right? Now we have seen how to deal with arrays, but I told you that Scilab supports complex number. So let us see how to work with complex numbers in Scilab. So for example, let's say I want to define z equals 3 plus for I and represent that in Scilab. This is how I enter that information. Z equals 3 plus, then percentage I. So please keep this in mind, percentage I multiplied with the imaginary part. Right? So the percentage I here denotes the imaginary part. You can see the complex number is assigned. And also there are certain operations with complex number. For example, how to find the absolute value of a complex number. So for a normal number, absolute value means the number without considering the sign. For example, if I take absolute value of minus of lux x, it will be x. Right? But for a complex number, to get the absolute value, you get the square of real part, square of imaginary part added and get square root. So also the Scilab, you can directly get this by typing the command abs, absolute value command is there. So you see abs within bracket z will give you 5. Similarly, another feature we like to see is how to find the angle. Angle is defined as tan inverse imaginary part of z divided by the real part. So in Scilab, you can get the tan inverse by typing a tan, then imaginary part of z by I mag z, and real part by real z. You will see the angle is appearing in radians.
Now pause the video and try to do this yourselves.
But let's say some of us like to see this in degrees. So how to convert this to degrees? In MATLAB, you have direct functions, but we will go with the basics. To convert radians to degrees, one has to multiply angle by 180 and divide by 5. Scilab, phi can be given by percentage EI. Now you will get the angle by multiplying with 80 and dividing by 5 like this.
Now pause the video and try to do this yourselves.
Okay, now you should be having a good idea of how to execute some useful commands in Scilab. If not, please get the help and try to be confident with that, because in the next few sections we need that to successfully complete our activity. As you may have seen, one of the main problems with executing commands like this is sometimes when you want to repeat a command with some modifications, you have to type it again and re-enter. But this is not practical in many of the situations. Instead, we like to have everything together and execute, which is called as a computer program. So in a computer program, you can write all your instructions into one text file, then compile them and execute. So in this section, let us see how to write the computer program. First, you type edit and enter. This will take you to the editor window. Just cancel here because it will directly take you. Yes. You get something like this, which you don't need at the moment. So simply select it and delete it. And here you get your editor window. In this editor window, you can type all your instructions one by one and then execute them. Okay, so let us try to do our activities rather than typing them on the command window. Type them here and run it. So to run it, what you can do is, before running, you have to, I think it's a good practice at the very beginning, you save it by giving a meaningful name. For example, is my prop 1. So I'll be saving it using a given name. Now you can start typing your command. And also it's a good practice to start with the clear and CLC at the beginning of your program. And also, if you want, you can put your own comments for your references later. So to put a comment, you have to put 2 backslashes and type whatever you want to type there. This is a good practice because it will be useful for you when you look at your program after some time. And also it will help others to understand your program. Okay, as one of our first program, what I am trying to do is I'm going to create a variation x versus time, but this time I'm going to make it x equals Pm cos omega naught t plus 5 equation, right? So we have learned in lectures we can create functions using trigonometric functions. So let me say my Vm, that is the peak value of my sinusoidal signal, is 230, which is the RMS value of the domestic supply. But since I want to get the peak value, I multiply it by square root 2. The relationship of the RMS value and peak value of a sinusoidal signal is given by RMS multiplied by square root 2 gives you the peak value. And then I will select my fundamental frequency or the pitch of the frequency as 50 Hertz. This means I will get 50 cycles per second. And as you may already know, this is the frequency of a domestic supply in Sri Lanka. Then I will convert this frequency F0 into frequency in radians per second, omega naught. Since we don't have omega naught, I'll type W naught here. So W naught equal to 2 times 5 times F naught. Then I will define my phase, some arbitrary value, let's say 0.7. Okay, now we have given all our initial values. Now the next thing I want to have is to create this signal, I need sampling frequency, because you know in computers these values of x are generated as sample. So I have selected my sampling frequency as 4000. That means for 1 second I am going to generate 4000 samples. So you know my sampling time is equal to 1 over sampling frequency. So I have created these two also. Next, I want to create my time vector, because I am going to create x with respect to time. So let's see how we are going to create that. And I am planning to have my time vector t starting from 0 to 1 cycle of the signal. And you can get 1 cycle of the signal by calculating the period, where period is equal to 1 over fundamental frequency, right? So for a 50 Hertz signal, this will be 0.02 seconds or 20 milliseconds. Okay, now I'm going to generate my time vector t equals, I'll start with time 0. Then what is my step size? Step size should be ts, and it will end with t. So I'm going to create a time vector which starts from t and goes in steps of ts up to t. Now I'll define my variable x equals Vm cos omega naught multiplied with t plus phi. And also don't forget to put semicolons. Finally, I will plot x versus t. So I think now you are ready with your first program, and then how to execute this. Before executing, I'll add line width also to my plot because I like to see it in a thicker size. Okay, and here we go. To run the program, there's a execute button at the top, or you have another option called as save and execute. When you click on that, you will get the result of your program like this. So now you can add whatever you like onto this, and because we have learned so many commands, and try to make this loops nicer.
Now pause the video and try to do this yourselves.